and getting out of control. He's a big bad beast, time to rock and roll. And getting out of control.
Hi there everyone, my name is Salis and my release system is 01DKM21F2030. So today our team is going to talk about vector and scalar in engineering mathematics. Okay, this is our introduction. First of all, we should know what is scalar and what is vector. Okay, scalar are quantities that have only a magnitude. For example, mass of an object, speed of a car. For example of scalar quantities are speed, potential, work, energy, and so on. Vectors, quantities that have magnitude and direction. For example, velocity of 20 millisecond due south is not the same as velocity of 20 millisecond due to west. Some example of vector quantities are velocity, weight, displacement, and so on. As you all can see, there's a line here A to B. Consider the line segment AB of length 3. This can represent a vector in the direction shown by the arrow of AB. This vector is denoted by AB. Note that AB is not equal to BA since the vector AB is directed from A to B, but BA is directed from B to A. An alternative notation is to represent AB by A, but we now need to refer to the diagram to find an intended direction. So the line segment of the diagram represents the magnitude or modulus of the vector. This is denoted by AB modulus or A modulus. And that's all from me today. Thank you very much, and my team members will be proceeding for the next subtopics.
Basic concept of negative vector. Vector is in opposite direction but with same magnitude as geometry. BA equal vector. Two equal vector if they have same magnitude and same direction. Here AB and CD are equal even though they have different location. Free vector can be translated without changing the vector itself. Vector addition. Addition of vector is V defined by triangle law. Consider two vectors AB and CD. If we wish to add AB to CD, we must move CD until C and B coincide. This process translation do not change the vector of CD. The sum of AB and CD is defined by the vector represented by the third side of the triangle. Here is the example AB plus CD. If AB is denoted A, CD by B and AD, we have C equal to A plus B. Another example is note that A and B is triangle form using A and B as two sides so that the head of vector touch the tail of the other. The sum of AB is represented by the third side.
So now we will have a look on vector subtraction. Subtraction of one vector from another is performed by adding the corresponding negative vector. Example, if we need to form A minus B, we do it by adding a negative B to A. And also we have the multiplication of vector. If K is any positive scalar and A is a vector, then Ka is the vector in the same direction as A, but K times longer. If K is any negative scalar and A is a vector, then Ka is a vector in the opposite direction to A and K times longer. So right now we will have a look on scalar dot product and its formula. If vector OA equals to A and vector OB equals to B, and theta is the angle between A and B, then the scalar product is given by A dot B equals to magnitude of A times magnitude of B cos theta. We also have a parallel vector in which the angle between A and B is 0. So the formula is A dot B equals to magnitude A times magnitude B cos theta. And we all know that when cos 0 equals to 1. So we get the final answer as magnitude A times magnitude B. Next, we'll have a look on perpendicular vector, in which the angle between A and B is 90 degree. So the formula is A dot B equals to magnitude A times magnitude B cos 90, in which we know that cos 90 is 0, so the final answer we get is 0. And we also have a parallel vector, in which angle between A and B is 180 degrees. So A dot B equals to magnitude A times magnitude B cos 180 degree, and we get the final answer as negative magnitude A times magnitude B.
So right now, we will have a look of the property of scalar product, and this is the result that we get. Here we have the formula, which is cos theta equal to A times B over magnitude AB. Then, let's have a look on an example of vector cross product OA cross OB. So now on the properties of vector product, which you can see right here, and how we apply the formula to find the area of parallelogram and the area of triangle. To find the area of parallelogram, we take the magnitude of AB cross with BC. To find area of triangle, we just have half the magnitude of AB cross with BC. Here is an example of question related to area. Find the area of triangle having vertical at P 1, 2, 5, Q negative 2, 1, 2, and R negative 3, 4, negative 1. PQ equal 1, negative 1, and 3. QR 1, negative 2, negative 1. PQ times QR equal 7, 4, negative 1. Modulus PQ times modulus QR equal square root 66. Area of triangle 1 per 2 modulus PQ times modulus QR equal 4.021 unit per second.